Yesterday, we introduced the idea of a linear function or a linear equation, which is the equation for a linear function. So it's a function that makes a straight line when you graph it. And we learned that one way that you can graph a linear function is by making a table of inputs and outputs and then putting those ordered pairs on a graph. Today, we are going to learn a second way, a different way of graphing a linear function. So I told you that by the end of the chapter, you're going to know 3 different ways to graph a linear function. So this is way number 2. Way number 1 is to make a table. Way number 2 is to do something that is called graphing using intercepts. So before we can graph using intercepts, we need to talk about what intercepts are. In a minute, we're going to fill in the top part of your notes, but I actually want to hop down to one of these graphs just for a minute. You do not have to write this down. We are going to use the graphs on your notes for something different. I'm actually going to erase this when I'm done. I just want to show you so that you can understand what intercepts are. So most lines have what's called an x-intercept and a y-intercept. So if you think about what the word intercept means, so if I were to say, I intercepted my friend in the hallway, well, that means that I ran into them or I caught up with them. I met up with them in the hallway. So that's what intercept means. Intercept means to run into or to meet up with. So graphs have x and y intercepts. So the intercepts are where the line runs into or meets up with each axis. So where the line runs into the x-axis, so I'm just going to put, sorry, I didn't mean to send that flying. I'm just going to throw a little line on the graph here just so you can kind of see what I mean. So if I put a line on here, where this line meets up with the x-axis is right there at that point. And then it also, that's the x-intercept. So it also meets up with the y-axis right here. So that would be the y-intercept. Now there's something special about intercepts that we have to understand in order to work with them. So the x-intercept is where the line meets up with the x-axis. So a line could potentially cross the x-axis at any of these different points. So it has to cross at a point somewhere on the x-axis. So it could be any of these points. Potentially could be a place where a line would cross the x-axis. So I want to think about just a minute about what the coordinates are for those points. So I could mark that point. That's 0, 0. I could have a line that crosses the x-axis right there. That's 2, 0. Maybe my line crosses over here. If it crosses over there, that would be negative 5, 0. So the thing that these all have in common is that in order to be on the x-axis, so that place where we meet up with the x-axis, always has a y-coordinate of 0. So that is an important feature or characteristic of an x-intercept. An x-intercept is always going to be on the x-axis because it's where the line meets the x-axis. So it will always have a y-coordinate of 0. Any point on the x-axis has a y-coordinate of 0. So I'm going to erase this to get it out of the way for what we're going to do in a minute. And we're going to come up here. So an x-intercept is the point where the line crosses the x-axis. And the x-intercept will always have a y-coordinate of 0. So it'll look like this. You'll have some number, whatever it is, and the second number will always be 0. Something similar happens with the y-intercept. So I'm going to come back down here. Again, you do not need to write this on your graph. I'm actually going to erase it when I'm done. I just want to show you. So where the line crosses over or meets up with the y-axis is called the y-intercept. So we can look at different places. So maybe my line hits the y-axis right there. Well, that's 0, 1. Or maybe it hits up here, 0, 4. Or maybe I have a line that crosses down here, 0, negative 3. So you can see all of the different points where a line might cross over the y-axis or possibly have a y-intercept all have an x-coordinate of 0. So in order to be on the y-axis or be a y-intercept, the x-coordinate has to be 0. So that is a feature of a y-intercept. which is going to be important in just a moment. So going to erase that to get it out of the way because we're going to use our graph for something in a minute. So the y-intercept is the point where the line crosses the y-axis. And the y-intercept, like I was just showing you, always has an x-coordinate of 0. So a y-intercept, or a point on the y-axis, is always going to be 0 and then whatever number it hits the y-axis at. So one thing I want to point out, because it's a good memory trick, it helps you to not get confused when you're calculating, which we're going to do in a minute, is that whatever intercept you're working with, its opposite coordinate is 0. So if I want the x-intercept, the opposite of x is the y, so the y is 0. If I want the y-intercept, the other part of the y, or the opposite of y, is x, so x is 0. So each intercept's opposite coordinate is 0. So if that helps you to kind of remember how that works and how that looks, that's a tip that you can use to help remember it. So knowing this, the whole reason why it helps to know about these is because if we can find the intercepts, then we can use them to make a graph, which is our second graphing strategy. The best way to explain it is to show it. So we're going to look at a couple of examples to show you how you can calculate intercepts and then how do I use those to make a graph. So we're going to look at two different examples. You'll notice that these equations are arranged differently, and that is intentional so that you can see that this process works no matter where things are in your equation. So the very first thing we want to do if we want to graph using intercepts is we need to find the x-intercept. I'm going to abbreviate x-intercept, and the y-intercept. So remember, at the intercept, each intercept's opposite coordinate is 0. So if I want the x-intercept, that means the y-coordinate is 0. Well, if I know that the y-coordinate is 0, I can go ahead and fill in a 0 into the y spot. So we're basically saying at the x-intercept, I know that the y, or the output, is going to be 0. So I could go ahead and make that output 0. So that would make my equation look like this. Well, now I can do some cleanup because we know that 3 times 0 is 0. And subtracting 0 doesn't really do anything. So 2x minus 0 is really just 2x. That just boiled down to a nice one-step equation. So we can undo that multiplying by dividing both sides by 2. And we get x equals 3. So that means this equation, if we graphed it, its x-intercept, or the place where it would cross the x-axis, would be at 3. And remember, we know what the y is. It's 0. So that is a point that we could put on the graph. We're going to put it on the graph in just a minute. Now we need to find the y-intercept. Each intercept's opposite coordinate is 0. So the y-intercept, the x, or the input, is going to be 0. So I could kind of do the same thing, but with the opposite point. So for the y-intercept, I know that x has to be 0. I can go ahead and put a 0 in the x spot of the equation. 2 times 0 is 0. And remember, this is the same as 0 plus negative 3y. So adding 0 doesn't really change anything. So 0 plus negative 3y would still just be negative 3y. Again, one-step equation. I can undo the multiplying. Y is being multiplied by negative 3, so I can divide both sides by negative 3. 6 divided by negative 3 is negative 2. So that means I now know my y-intercept. So remember, the y-intercept has an x-coordinate of 0, and I just figured out the y-coordinate is negative 2. So now I have 2 points. I can put those 2 points on the graph. Those are coordinates I can mark. 3, 0 is right there. That's the x-intercept. It's on the x-axis. 0, negative 2 is right here. That's the y-intercept. Yesterday, we said that when you're making a table, because tables are very calculation-based, it's a good idea, if you can, to choose more than 2 points to check your work. We can't really do that with intercepts because we only have 2 intercepts, an x-intercept and a y-intercept. But yesterday, we did say that the minimum number of points you need in order to draw a straight line is 2 points. And we have 2 points. So with both of those points, marked on the graph, you can see where the line's going to go, because the line has to go through both of those points. So that means I can go ahead and draw my straight line. And remember yesterday we talked about making the line nice and long and putting those arrows on the end to show that it keeps going. There's other points in the pattern if we keep going out. So that's how you graph using intercepts. We're going to try one more just to help you make sure you've got the hang of it, and also to get you thinking about the fact that this works with your equation in a different format. So this equation is arranged a little bit differently, but the process still works exactly the same. So to get the x-intercept, its opposite coordinate, or the y-coordinate, is 0. So if I want the x-intercept, I could put a 0 in for the y. So if I put a 0 on the y spot in this equation, it's going to look like this. Now, this will still work. I just have a little bit more work to do. This is a two-step equation, but we can solve a two-step equation. So if I want to get x by itself, I get rid of the constant term first. So subtract the 4. 0 and -4 is -4. And I have 2x left. There's my one-step equation. So now I can divide by 2. So -4 divided by 2 is -2. So x is -2. So that means my x-intercept is -2. And remember, y is 0. So there's one point. I can mark that on the graph. It goes right there. To get the y-intercept, I make the opposite coordinate 0. So if I want the y-intercept, I'm going to make the x 0. So if I put a 0 in the x spot in the equation, it looks like this. 2 times 0 is 0. 0 plus 4 is 4. And since y is already by itself, I have the answer. That was nice and easy. So remember, at the y-intercept, the input, or the x, is 0, and we just figured out the output, or the y, is 4. So that's my y-intercept. I can mark that on the graph. 0, 4 is right there. Now that I have 2 points on the graph, I can see where my straight line goes, because it has to go through those 2 points. So I could go ahead and make a nice long line through those points, put my arrows on both ends to show that it keeps going. And we've got those nice straight lines that we were getting yesterday. So this has the same end result as making a table, but it's a different strategy. A lot of people like this strategy a little bit better than making a table because they feel like it's a little bit faster. It also causes people to ask, well, why would I ever want to make a table again if I could just use the intercepts, because they're fast to calculate? So one thing to remember, and why we learn how to make a table, the intercept strategy will only work for linear functions. So it will only work for things that you know are a straight line. The nice thing about a table strategy is that we could use a table to graph what we call a nonlinear function, or a function where the graph is not a straight line. That's something you guys will learn about later, but that's why it's still good to know that table strategy. So that's a question I often get asked after I teach intercepts. People ask me, why would I ever want to make a table again? Because there are other types of functions that you need to know how to make a table for, because table is your best strategy. So, and that also is a good reminder of this strategy as well. It only works for linear functions, which is fine for now because we're working with linear functions. So your notes should be filled in. You should have your top part filled in. You should have all of your work filled in and your graphs filled in. If your notes look like mine, then you can go ahead and move on and try the practice assignment.